Oh gosh, no. Please no. Alright, so I also think can one of you guys try talking for me real quick? There we go. Alright. I I disabled it for the lecture last night. So we're looking at transforms because the question that came up by Gloria here was when I run predict, sometimes my decoded preds and my predictions will be the same because learn.predict will return actually three different bits. So let's take a look at that real quick. So if I go into learner, predict, we can see that I can pass in, actually, we'll go ahead and open up a notebook while we're at it. We're just doing this on the fly, it's fine. We can pass in three different parameters to learn.predict. We can, besides the input, we can pass in if we want to return the original input or the original X. We can pass in if we want a decoded output, and then it'll also give us the raw output. So that's what this does right here. The overall functions look almost the exact same in terms of keyword arguments and what gets passed in. And so the original thought would be this decoded method would say, grab maybe the class labels, sort of like it did with FastAI v1 when we did learn.predict. So like if I was doing dogs and cats and, I did learn.predict, it would, for instance, tell me like this is a sheep. That is entirely dependent on your loss function. So that doesn't actually go through and decode based on sort of what's available, like a key or a dictionary of what like class to index would do, where we have a dictionary of like, 0 is dog, 1 is cat, and this is actually stored away in memory for us. I'm going to go ahead and keep the chat open. Zach and my cats. Yeah, this is on my other account, and I haven't actually disabled the cats yet, but that's okay. And so what it's really looking at is these encodes and decodes functions. And the best way that I can sort of go about describing that is a post I made in the vision thread that I will go to in a moment. Because I came to this realization yesterday of a particular behavior. So say, for instance, I have two different models, all right? And I can create one data loader that works on these two different models so long as my inputs are the same. Now that, as a whole, makes sense because I'm just passing in my x's, right? Well, I can also pass with decoded as true for the same data loader. Now, at first, we would expect that to completely break because we would expect the decoded values to be directly related to whatever my data loader is. So I wouldn't expect, say, a segmentation data load, segmentation models with decoded to work with a classifications data loader. That's actually not true. So Sylvain points out here, decoding is only done from the loss function, and that's why it works. And so we can look at that in, say, I believe it's in the metrics. I'm still trying to find out exactly where this is located. But the general concept is, let me see if I can find where this actually is stored. We're going to do this live, so it's going to be fine. Maybe it's here, decode. Yeah, so if we do loss func, and I want that loss function to be, where is this at now? So we'll look at cross entropy loss flat, because it has a decodes function. Where are you stored at? FastI2 layers, that's where it is. All right, so we'll keep that one open for now, because that's useful for us. If we go over to layers, which is where a lot of useful functions live, so in our case, we have cross entropy loss here. Yeah, I could zoom in a little bit. So like we have cross entropy loss flat here, the binary cross entropy loss, mean squared error loss, all the ones that FastAI claims is its special loss functions that it uses instead of the like torch versions. Let's go figure out why. So if we look at cross entropy loss flat here, it inherits this base loss function. And if you look at what it's doing, whenever this activation occurs, so I believe the order of it itself is activation occurs when we are in the middle of training. So like we have this softmax here, and so whenever we are getting so when we say, for instance, I kind of looked at this yesterday a bit, but whenever we take like a raw probabilities of like 0.2, 0.3, and we do this on a batch level, right? So we'll have, if say we have two classes, our raw predictions could look something similar to this, right? A softmax, if this is rounded to like 0.8, is being applied to where all of these probabilities sum up to 1. And that's the behavior that cross entropy loss flat will do for us. That's why when we do like learn.predict, it doesn't just give us the absolute raw values. That's because this activation function subfunction is being called every time we call cross entropy loss flat. Now, one thing you'll notice though is like if we do a simple model with cross entropy loss flat, so like we'll do path equals untar data urls.mnist, and I'm going to cheat real quick and go look at my own code for how to quickly set this up. I do this all the time whenever I'm trying to build something because it's a lot faster if I just have an example there for me. So after this loads, if you don't quite understand the, I believe this is a mid-level API, that's okay. Eventually, Jeremy will go over it. But I am just going to go ahead and very quickly copy all of this over to my notebook for us. I'd focus on what it's kind of actually doing, but since we're generally trying to stay on the topic of the loss function specifically, I'm going to try and keep the discussion focused on it. But if we want me to sort of walk through what's happening here, I absolutely can. And then we'll just very quickly do CNN Learner. We'll do data loaders, ResNet 18, and then we'll just say metrics equals accuracy. Now, if I quickly fit for one epoch, and if this takes forever, yeah, it's not going to like me. Learn.model at 0, 0. Well, I thought this would be easier in my head, but it was not. For those wondering what the heck I'm doing here, I'm modifying the first layer's input to accept a one-channel image. Now, this isn't the best way to do it. I'm just simply doing this very, very quickly. Ideally, you'd want to, like, copy the weights over and GPU. But essentially what I'm going to show here is after we finish training this model, we can look at its output from predict, just because I'd rather visualize it for us. But in the meantime, we'll go back and look at this particular model, or this particular loss function. So the general idea is when we call the with decodes, it'll run this one line here. And so when you're using like cross entropy loss flat as your loss function, ideally the decoded predictions should look different from the raw predictions. It won't be class labels exactly, they'll be our encoded class labels. So if we quickly go ahead and fit, this should take absolutely no time at all. Once it gets up and going, all right, so it'll take about a minute, so we'll let that train in the background. But conceptually, does that make sense, or do I need to go and explain the decodes, encodes a little bit better? Because we can look at that in augment too. Do you want me to try and re-explain that again, now that we're sort of more organized? Or is there any questions specifically I can answer?
So Zach, I have a question. So when we do learn predicts in your example, it will decode to softmax because in your loss function, there is a f softmax. So when we'll say learn predict, it will call this activation or not, or it will just return.
This is so consider activation here the raw values that it gives back.
So the raw values will be already softmaxed.
Yes. And that's why, like, whenever we're doing, the multi-label classification, where we want to take, all those raw values and apply some sort of a threshold, if we look at BC logits flat, that's what that does. Notice our activation here doesn't run a softmax. It applies a sigmoid on those raw values.
I see. So, okay, and one more question. So let's say we are doing inference not using learn.predict, but just normally through model. So we'll load the batch and we do learn model and pass the batch. Then this will give us not softmax. It will just give us whatever we define in our model on the last layer. Correct?
Yep, exactly. So if we
and then after this we have to take softmax if we are doing like yes. We can take softmax if we are doing multi-class, or we can just do whatever we want.
Exactly.
Okay, good, thanks.
Absolutely. So like if we do learn predict, and we'll just use a quick item here. Now, we can see that we get a 9. Predict specifically actually does have the capability of returning the actual class label. And I believe the reason for that is unrelated exactly to the loss function. Yeah. What predicts' behavior to get that class label a 9 comes from this line of code right here, which is decode batch. And this will take a batch of this input, or actually this input, sorry, so our softmax that we used, and go through and decode it. So if we, for instance, do learn.getPreds, because if we follow the learn.predict code, it will call learn.getPreds with a data loader of just one item. We look at these predictions. So in getPreds, we can pass in with input equals true. And so I can do like input x, y. I think this is right. Going off the top of my head here. But decode batch is what will actually return to you the class value. Because it'll look at your inputs, look at your outputs, and then attempt to get back as close to your original items as you could. So we'll do like learn.dls, decode batch, simplify, input, simplify, with decoded equals true. Because it wants decoded prediction, sorry. And actually, I think it's not going to like me there. Decode. And so now we can pass this sort of input and this decoded prediction, which right now this decoded prediction contains the softmax that was done. Right? If I did that right in my head. Yeah. So this is that, actually this is that argmax that was being performed. Sorry. The y has our returned tensor categories, and then x here should be our, there's the softmax being applied. Does that make a bit more sense where everything is coming from? And then I can pass the tensor category decoded ones, I think I got the order wrong there, into decode batch. And so now, if I get these results, it'll go ahead and decode them based off the fact that we had tensor categories at one point and we had tensor images at another point. We do res at 0, 0. Sorry, 0, 1. This is the image that we passed in from the data set. And then the next one is our label. So decode batch is how you take any of your predictions and get back sort of what the original values were, or to sort of go back through and grab your Y label. And so that's why getPreds doesn't quite do the same thing as predict. Does that make sense? And sort of explain why the decodes is important here? And why with decoded is different versus, or can be different compared to just the raw outputted values. Awesome. All right, I'll go ahead and stop sharing my screen and the cats for a moment and